Conductors. The solids which have conductivities range from 10 raised to 4 to 10 raised to 7 per ohm meter are known as conductors. Metals have conductivity in the order of 10 raised to 7 per ohm meter and hence are the best conductors of electricity. Conduction of electricity in metals. Metals like gold, copper, aluminium, etc. are very good conductor of electricity. They can conduct electricity both in solid and molten form. The extent of conductivity in solids depend upon number of valence electrons. In metals, the valence band is partially filled and usually overlaps with the empty conduction band in such a way that there is no forbidden gap present. As a result, the electrons from the valence band can easily move to the conduction band. This results in conductivity in metals. Insulators. Those solids which do not allow electricity to flow through them are known as insulators. Conduction of electricity in non-metals. Non-metals like plastic, rubber do not conduct electricity. In these solids, the valence band is full while the conduction band is empty. Even the forbidden energy gap between the valence and conduction band is large. As a result, huge amount of energy is required to excite the electrons to the conduction band. Practically, it is impossible to provide this huge amount of energy to excite electrons and conduct electricity. Therefore, most of the non-metals are insulators, semiconductors. The solids which have conductivities between conductors and insulators ranging from 10 raised to -6 to 10 raised to 4 per ohm meter are called semiconductors. Conduction of electricity in semiconductors. The conductivity of semiconductors like silicon, germanium, etc. are based on temperature and addition of impurity. In semiconductors, the valence band is almost full, while the conduction band is mostly empty. The forbidden energy gap is quite narrow. Thus, the heat energy available at room temperature is sufficient to excite some of the electrons from the valence band to conduction band, which results in the conduction of electricity to some extent. The conductivity of semiconductors increases with increase in temperature, since more electrons can jump to the conduction band. Now, let us study types of semiconductors and how conduction of electricity takes place in semiconductors. Types of semiconductors. These are two types of semiconductors. Intrinsic semiconductors. The semiconductors which can conduct electricity in their pure form are called as intrinsic semiconductors. At room temperature, the conductivity of these semiconductors are quite low. Example, germanium and silicon are intrinsic semiconductors. The process of adding small amount of impurity to an intrinsic semiconductor is known as doping, and the impurities are called dopants. Extrinsic semiconductors. The semiconductors which are formed by adding impurity to an intrinsic semiconductor are known as extrinsic semiconductors. Example, when germanium is doped with arsenic as impurity, it becomes extrinsic semiconductor. Now, we know what is doping. Let us study how an intrinsic semiconductor can be doped. Doping can be done in two ways, with electron-rich impurity or with electron deficiency impurity, as compared to the intrinsic semiconductor. Electron-rich impurities. Both silicon and germanium belong to the group 14 of the periodic table and have 4 valence electrons each. When silicon is doped with small amount of group 15 elements such as phosphorus, arsenic, its electrical conductivity increases. In pure silicon, each silicon atom uses its 4 valence electrons for the formation of 4 covalent bonds with the neighboring silicon atoms. When silicon is doped with some group 15 elements, then some of the positions in the lattice are substituted by atoms of group 15 element. The group 15 elements have 5 valence electrons. After forming the 4 covalent bonds with silicon, 1 excess electron is left on them. Since this electron is not involved in bonding, it becomes delocalized and contributes to the electrical conduction. Silicon doped with the group 15 elements is called an N-type semiconductor. The increase in conductivity is due to negatively charged electrons. Therefore, semiconductor doped with electron-rich impurity is called N-type semiconductor. Electron deficient impurities. Electrical conductivity of silicon or germanium can also be increased by doping with group 13 element such as boron, aluminium or gallium. Group 13 elements have only 3 valence electrons. When silicon is doped with some group 13 elements, then some of the positions in the lattice are substituted by atoms of the group 13 element. The group 13 elements have only 3 valence electrons. Thus, they form only 3 covalent bonds with silicon. One of the valence electron of the silicon remains unpaired. This causes an electron vacancy or electron hole in the system. To fill this vacancy, an electron from the neighboring atom jumps into an electron hole, creating an electron hole at its original position. When the electric field is applied, electrons migrate towards the positive electrode by filling the holes, making it appear as if electron holes are migrating towards negative electrode. These holes are responsible for electrical conduction, and the resultant semiconductors are known as P-type semiconductors. Effect of temperature on electrical conductivity. Electrical conductivity of metals decreases with the increase of temperature, whereas the conductivity of semiconductors increases with increase in temperature. Why? In metallic crystal, the electrons are free to move throughout the crystal. However, the metal ions are fixed in position and can only vibrate. When a metal is heated, the metal ions start vibrating more vigorously, and as a result, motion of the valence electrons through the crystal is hindered. Thus, electrical conductivity of metals decreases with increase in temperature. In semiconductors, the energy gap is very small. A slight increase in temperature or On the application of small voltage, some of the electrons from the valence band jumps to the conduction band and show low conductivity. Substances exhibiting this type of behavior are known as intrinsic semiconductors. Examples: silicon, germanium, etc.
तो बेटा बात कुछ ऐसी है कि वीडियो पसंद आई हो तो ज़रूर से लाइक शेयर सब्सक्राइब कर देना, बेल आइकन प्रेस कर देना ताकि सारी वीडियो का नोटिफिकेशन मिलता रहे। और यार बटन दबा ही दो, पसंद आई हो या ना आई हो क्या जाता है, एक लाइक शेयर सब्सक्राइब में क्या जाता है, कुछ भी तो नहीं जाता। तो दबा दो, बटन दबा दो, आइंस्टाइन बोल रहा है।